Okay, hello. My name is Jonathan, and for the past 2 hours or so, not today, I did it a few days ago. Uh, I've been trying to recreate a 4-bit display that we see in multism in Minecraft. So before I show how it all works, the logic behind it, the circuits, I'm just going to quickly run through the test. So right now, this is what the input is. These two switches have the manual input. Right now, all of them are off, so it's 0, 0, 0, hence the big 0 displaying. This is the lowest bit, that's the highest bit. This here is a counter that counts from 0 to 9 and then breaks, kind of. I'll show it when I get there, but yeah, that's 0. That's displaying a 1. That's a 2. That's a 3. And as you can see, these lanterns are lighting up with the bits that are on. That's a 4. That's a 5, and as you can see, the back end of the circuit is bring the signal up as this circuit's updating, but we'll get there. That's a 6. The signal's traveling up there. There's my 7. Here comes 8. And 9. And this is where it stops. I didn't program it to accept anything else, just 0 through 9. But when you click the button, it doesn't do anything. It won't display anything because none of the requirements are met. So right now, I'm pretty sure this is the binary for 10, I think. But to fix this, I need to do this and this. So yeah, wondering what these little segments are. That's what this is. This is a T flip-flop. It's very similar to the D flip-flops and the J flip-flops we see in multism, in the sense that it can store a charge. So press the button or send a signal up here. It switches. Send signal again. Switches. It remembers the charge that's given to it, and it inverts when other one's given it. But we're getting ahead. How did this happen? So how did I build it? So Redzone's a system in Minecraft that is very similar to circuitry, in the sense that it acts very similar to circuitry, but it has its own quirks because this is a game. The maker of the game, Notch, I believe his name's Michael. I don't remember exactly, but he originally worked with circuits, but he hated going to class, but he loved. No, he hated working in the field, but he loved the concepts behind circuitry. So he programmed it into its game. But again, Redzone acts slightly different from actual circuits, but it does act very similar. So in the sense that Redzone is a binary system. It has an off state, which is 0, when it's unpowered, or an on state, which is powered, which is 1. Redzone also, unlike circuitry, has an actual limit to how far it goes. So it can go about 10-ish blocks, up to 12, but I don't know. I didn't count. So Redzone has a limit before it straight up stops. So right here there's no power, so it's a 0, but here there's a very little amount there, so it's a 1. And these are repeaters. They act as one-way gates, they act as delay mechanisms, and they also repeat the signal, so it can go farther than, I think, 12 blocks. So using this on and off state, we're able to create, and the torches, we're able to create logic gates. This is a NOT gate. The signal going in is a 1, signal coming out, 0. Signal going in now, it's a 0, signal coming out, 1. This is an AND gate, though in actual circuitry this would act like a NAND gate, but this is the Minecraft's AND gate. So if any, and mind you, these are all expandable, but if any of the signals coming in is a 1, it powers this block, which turns off the torch, with outputs a 0. So if all of them are on, still 0. I mean, it's still 0. One of them's off. Not both. It's on. This is an OR gate, but it is an OR gate, but we don't consider it an OR gate in Minecraft. It's a thing you do. Also, yeah. So any signal from the left or from the right side or the left side, boom, it goes through. Also, like I said earlier, these act as one-way gates. Signal goes one way, it doesn't go back the other way. So can be seen better here. Goes one way, not the other way. Also, I put this all the way up. It delays. Also, another cool thing that redstone does that I'm pretty sure circuitry doesn't do it. It can travel through exactly one block. There are quirks, but generally speaking, one block. That's a piston. See, goes through one block. Can't jump an air gap. There are two types of pistons: sticky pistons and non-sticky pistons. These are the sticky pistons, and the only difference is the sticky pistons drag the block back. Redstone block. Those are torches. The redstone block constantly output a source, and so do this one, but these ones are more directional. It sends it in a direction, though you can get a source going this way. That's a clock, and it burned out. One of the differences between the torch and the block, the torch can burn out. And the block, well, it doesn't burn out at all. It's a slime block. I used one earlier in the build, but that's made things stupid, but essentially a slime block drags block up and down. So, how does this work? So right now, this block that the torch sitting on has no power in it, so it's a 0. So this is not affecting the torch, which is a 1, which then sends a signal into this block, making this block a charge of 1. That 1 inverts the torches, giving them 0. This block does have a charge in it. It's now a 1, and well, it's now a 0, but the 0 doesn't cancel out the 1 here, so it allows it to go. This 1 travels to the block, cancels out the torches. Well, it's not, I think it's not really accurate to count in 1s, 0s, they just invert each other from 1s and 0s. So, flick the switch, he sends power on the block, turning off torches, which inverts everything. The cool thing about this thing, it brings a signal straight up instantly, like in the exact frame, in the exact redstone tick. And ticks are like 1/7 of a second, I believe, or 1/14, one of the two. I haven't done redstone in a long time, but yeah. So, how does this work? So first and foremost, the signal that goes here is repeated once. It's brought down the line and it's fed to the bottom of this redstone tower. The redstone tower will deliver the signal exactly how it is down here to each layer at the same time as was demonstrated over there. So the layer, it brings it up exactly, and each layer tests for a number. So there are 10 layers, 0 through 9. How the layers tested? Well, so wait, it'd be easier if I just show. Yeah. See, all these inputs are 0, and the topmost layer is 0. I just skip the inverted layer and just draw a signal from the not inverted layer. But if I make this a 1 or an 8, you can see the signal travels up here. So the entire notion of these layers. So this top layer tests for 9. So 1, 0, 0, 1. I want to invert the 1 signals coming in so that it doesn't send the power. So it doesn't send power. Because if there's power in this line, this torch is off. So see, there's a 1 here powering him, turning him off, but that's a 0. He's sending a signal which doesn't turn him off, which sends a signal to him, and that turns off this torch. And these torches are off, so they don't send signals. So if I were to go back here and flick on this one, come on, fly. 1, 0, 0, 1. As you can see, there's a 1 here, going here, turning him off. If this torch was powered, if there were any power running to the middle one, so say we turned on the second bit down there. Let's break this real quick. this would send power, turning him off, and, well, this isn't a program thing, so it's not going to display anything. So, yeah, torch back there. So, yeah, sending a 1. So, now I will say that I made this needlessly complex because I didn't want to hook up each individual layer to its corresponding circuits, though in the long run that would have been easier. I wanted to play around with virtual circuits. What's this? Okay, that's 9. I wanted to play around with the virtual connections, not virtual connections, the wireless connections. And, well, putting all the connections in a tight place made it rather annoying to try and connect the dots here. So, each layer tests for a number. Each number is comprised of different components. There is the top circle, the bottom circle, this line, that line, the 3 mid segments, a line that turns on this line but turns him off, one that turns this line but turns the bottom one off, one that turns on this line but negates the bottom, and one that turns on this line but negates the top. I will show those lines, right now. So this pink line here turns on that top circle, that green line turns on the bottom circle, the orange line turns on the 3 in the middle, this dark green line turns on that first bar, that bar over there. That blue line over there turns on this bar, and up here there are different circuits that send there's certain circuits that draw back the blocks. I can show it right now. That draw back the block. So if this was like a 2, that block, this piston would have been drawn back, and it will have negated that line. But this is sending a signal to this line and the circle, so that line is kind of cleared on 2 fronts. So yeah. Yeah, if I quickly show a different number instead of 9, so let's do 5. 5's the fun one. So 5. 5 is 0, 1, 0, 1, and if these 2 are 1s and those are 0s, so it would invert this line. Let me just quickly do that. Yeah, 5. So as you can see, only 1 torch zone is ever on at a time. If there's 2, we'd have overlap, and it can only turn on 1 at a time anyways. So yeah, this works. This sends a line here. It sends a line here which powers this block, which sends power through this block. What was this block being used for? Oh, this is using 8. Oh, right. It's using 8, yeah. Sends blocks with this line, which goes down to here. And as it's on the way down, it turns off this torch, which retracts the block, which kills this top line. Which, since that top line is killed, this top bar is killed. It goes down, it still strikes the bottom of the line so that the bottom one is hit. Then it strikes it strikes the orange line to light the 3 in the middle, and then it just lights the top one of the dark green bar, but through the top circle. So yeah, essentially I connected each signal up to its corresponding circuit. Granted, this will look a lot more true to actual circuitry if I had connected individually and not used the command blocks. So yeah, how these command blocks work, they're kind of interesting. Multisystem doesn't have this. I don't think circuitry has this in general, but this works on a NOT gate essentially. This bottom block places down the redstone blocks. This top block erases them by placing down an air block in the exact global position that I want it to be. So this one is the top of the orange line. It places down this block. So what's turning it on? Yeah, the bottom one. So say I break him real quick. This turns on, which kills a block down there. And if I put that torch back, turns them off, line the block to go back. So yeah, each one strikes its own lines, though some of them do their own little cheats. Like for example, with 8, how 5 works, it strikes the bottom circle and the top circle while negating that one. How 8 works, it basically, if I show this real quick, how 8 works, it sends a line down this way to where 5 is. Let's see, let me see if I just show it. And boop. Yes, neat. So how 8 works, it sends a line down, and this is the 6th level. Alright, now 5th, yeah, 6th. This is 6th, that was 5. I did this 2 days ago. So now the 6th level, it strikes everything that 6 does, but what it does, it also goes down to this line, turning off this block, retracting this block. And this line specifically turns off that top bar, so it negates the negation. So yeah, there's nothing really much more to say. Again, if I connected it individually, each one to its own segment, it would have made this a lot less complicated, but it would have been a lot less fun if I did that. So yeah, last thing to really explain is the T flip-flops. So how these are built, if anyone really cares. 2 pistons, sticky or not. Redstone block. Block. Torch. Torch. Now there are far more compact ones. This is the one I use because it looks cooler. Moves it over and moves it back. And if you remember the one homework assignment we had where we basically linked up a bunch of these, and each one stood for a bit of a number, like the one that was like our group did counted to 766. This would all count as one of those rows of 4. Yeah, I could actually make a counter in here, though it'll be a lot more laggy. I could probably figure out a way to reset it and have it when it strikes 9, it resets everything. So yeah, there's nothing really much more to say. Anyway, like the only reason why I wanted to show off this is because turf is a cool idea. It's a cool concept, I will give it that much, but in my opinion, Minecraft is a cooler concept. And if turf was replaced with Minecraft, that would be cool. I know it's never going to happen because turf is probably much cheaper. And frankly, you don't need everything Minecraft has to teach a class in Minecraft. To teach a class, essentially. To teach a class, you just need to speak and need people to be there. Minecraft is a little bit more hands-on, in my opinion, where you can experiment with certain circuits and that stuff, though with its own logic of its own kind. So, its own logic and form of gravity as well. So, yeah. This is a 4-bit display.